I'm Matt from Full Send Engineering, and this is episode number 4. Now, I'm very happy to introduce our next guest on Full Send Engineering. It's Kate Leone. Kate is a mechatronics engineer who's grown up actually in Hong Kong. It's a very interesting story, which we're going to get into. Now, her career's already spanned from working in Asia. She's done humanitarian work in India and Nepal, and now she's working on some of the most complex communication systems on major projects here in Sydney. Now, what stands out about Kate is her ability to not only speak to, but get what she needs out of people at all levels. So she's got a really way of communicating, and it doesn't matter if she's communicating with the CEO or with someone from a site crew. She's really got a way to speak her mind and get exactly what she needs. Now, she's got a passion for the betterment of the industry, and that's probably why she's here today. And she has also got a passion for leaving a positive impact on the world. Now, I'm really excited to have you here today, Kate. So we might just jump straight in.
Yep.
And I wanted to talk a little bit about your experience growing up in Hong Kong.
Yeah, so I was actually born in what used to be a small country town, not anymore, Camden, down southwest of Sydney. And I remember around the age of 5 or 6, my parents coming home one day and going, "Girls, we're moving to Hong Kong."
Wow.
And I had absolutely no idea what that was, let alone what that meant. And, you know, we finished out half of that year of school and moved over to Hong Kong. I was halfway through year 1 in, Camden Public Primary School, and moved over to Hong Kong where mum and dad had gotten jobs working as teachers in international schools. So we all started off in the same school over in Hong Kong, which was an English school system, international school, which was an incredible change to go from sort of the Camden small town to all of a sudden being exposed to so many different cultures, so many different types of people. You know, there were kids rocking up to school in Porsches and Ferraris, and then I'd be taking the bus. But just such a privileged upbringing. I remember when I first landed in Hong Kong with mum and dad, it was nighttime, and I was this little 6-year-old bright-eyed kid and had never seen so many skyscrapers in my life. I mean, the most amount of skyscrapers I'd seen was whenever we came into Sydney for a weekend.
Yeah.
And it's just a different level. And I remember turning to my mum, or not so much remember, my mum tells me the story a few times. I remember turning to her, and we were in the taxi ride from the airport to Hong Kong Island, and you go over this bridge and you just get the view of Kowloon Side and Hong Kong Island. And I just looked at her and went, "Wow, this is a fairyland. I never want to leave." And, that it was my home until I was 18. I still consider it home as well. It's now a shared home between Hong Kong and Sydney. And
That was like the start of your memory, when you were 5 or 6.
Absolutely. Yeah.
You must have had such a crazy understanding of who Kate is.
It was very interesting. I remember coming back to Australia for our summer holiday, which was winter here. And it was so interesting. I'd always walk around, and I kept in contact with a few of my friends. And I remember a lot of the kids. So my really good friend here, she would tell them that, "Oh, my best friend's coming over from Hong Kong," and then she'd show them photos, and they'd be like, "What? If she's from Hong Kong, why does she look like that?"
She's like an Aussie kid.
Yeah. Why does she have this little international Aussie accent?
Yeah.
But yeah, so it was a really interesting identity to have, and it formed how I was able to talk to people for sure, because I was exposed to so many different types of people, and at a different level as well. And I think especially because my parents are teachers, I got exposed to being able to talk to authority in a bit of a different way.
Okay, this is interesting.
Yeah, I'd rock up to school and obviously be like, "Oh, hello, Miss XYZ," and then have to come home and they'd be there and I'd be pouring them champagne and cutting up cheese boards for them and have to talk to them as if they were friends, which they were, like family friends. And it's just it's really set me up to be able to view different levels of authority and different types of people as people. And it's meant that coming into a career in engineering, I think as well, standing out a bit as a female mechatronics engineer, it's meant that I can go into scenarios and just talk to people and just ask for what I want and just talk to them on a human level. And I think they really respond to that a bit better than what you notice a lot of grads doing, and a lot of younger engineers especially, where they come into scenarios with authority or people who are their bosses or their bosses' bosses, and they get nervous and they go, oh, I can't talk to them like that.
Yeah.
Or there's no way that I could say this thing to them or joke with them in the lift as we're going up and down to the office. And I go, why not? You know, like I've managed to develop some really good relationships with people throughout the industry at different levels because I've just talked to them
as like
if,
had a joke with them.
Yeah, as if they're my teacher and I'm pouring them champagne back in the living room on a Friday afternoon.
That's
you
awesome.
know?
Yeah.
Yeah.
So you grew up in Hong Kong from when you were 6, and then it sounds to me like you had a little bit of a spark for architecture, considering you're, driving around the city and you're pointing at the buildings and thinking, this is a fairyland, and like, how do you go from that into getting into mechatronics of all things?
Yeah, look, it's quite an interesting story, and there's almost no logic behind it. I absolutely loved architecture, and Hong Kong really was the spark for that. I mean, you walk around, and even the bathrooms in hotels and shopping centres are just beyond any level that you are exposed to on such a scale anywhere else. Maybe more so now, but back then in sort of 2000, 2001, it was just such a different level of design that you got to be exposed to. So, I grew up being the arty drama kid, and I loved maths, but I was really terrible at it in comparison to, the standard that's set on an Asian international school levels. So I always grew up knowing that I wanted to be an architect. Or, if I didn't get into architecture, maybe as a backup interior architecture or interior design, and really kind of stay in that design space. But then when I got to sort of 16, I had a work experience. One of my friends in school, her dad was an architect and worked in this really big firm. And I sat with him in meetings and shadowed him for a day. And I thought, oh, this is really cool, but it seems like until you get to the big level, you might not actually be designing that many cool things. You're kind of designing like lighting features or how a door swings open or toilets.
And I mean, that's not a dig, is it?
No. And it's incredible. I had this idea about architecture and seeing the buildings that I was seeing in Hong Kong, thinking that I could automatically go straight into this level of architecture that people take their entire careers to get to. And that was sort of the start of me thinking, oh, maybe architecture is not necessarily the best thing for me. And I also knew that they weren't paid very well. So when it came to me moving to Australia and applying for universities, obviously I still put architecture first, because since the age of 8, that's what I wanted to do. And I'd kind of built my identity around being this artistic, creative lover of the built world. But then I went, oh, what do I put as a backup now? And in my little 18-year-old brain, I wasn't too sure how to process it. So I went, well, if I don't get into architecture, or if I decide not to do architecture, I don't want to be working with what I could have been. So automatically that in my brain, I was like, well, I guess civil engineering's out of the question. And then I went, well, the next logical thing is then mechatronic or mechanical engineering. At the time, I didn't actually know what mechatronics was, so mechanical engineering. And got into mechanical engineering and just never really looked back. I had this idea. So after first year, I found out this really cool thing called mechatronic engineering, which wasn't so much a thing back when I was applying for degrees. And I went, oh, shit, yeah, robotics. How cool. I'm going to change over to this degree and pick it up. So I did mechanical and mechatronics, which at the uni I went to, they offered you to be able to do both of those as kind of like a dual major. You just got rid of all of your electives in order to do that. So picked that up and always thought, you know, if engineering doesn't work out, then at least I've got these really cool robotics skills and I can go back into art somehow and build artistic robots or build robots for film sets or stuff like that. And, you know, like maybe still it could be a backup because it's such a cool career. But, you know, since actually coming into industry, working a little bit throughout uni and working as well overseas and doing all these cool things, I've realized that I actually do love engineering. I've always been the kid that has loved knowing how things work. And engineering has definitely brought me that. And you know what? I think it actually is a lot more creative than people give it credit for as well.
Look, I think sometimes we all like expect when we start to do something that we're going to like fall in love with it straight away. Yeah. And like for me, like I'm kind of like that person that just loves getting into things and you know, can get passionate about pretty much anything, you know. But for some people, it's a long burn. And I know while you were doing your degree, you were looking at different types of work experience. And I know the story of how you got onto your work experience is pretty funny. So why don't you tell us a little bit about how you came across going back to Hong Kong to do your work experience through uni?
Yeah. So as part of the UTS engineering degree, when I did it, at least, we had to do the degree in engineering and then the diploma in professional practice. And as part of that diploma of professional practice, you have to do 2 6-month internships. And this is actually why I picked that degree, because I figured that it was a good differentiator. You know, a lot of the universities in Sydney have quite good names, and the differentiator really is your work experience. So the first internship of 6 months you have to do before you reach a certain amount of credit points. And I was really starting to get to those credit points and getting a bit nervous about where I'd be able to get this internship, because I was cold calling places.
Wow.
I'd go through the UTS online career hub and be looking at all of these job applications for undergraduate engineers and junior undergrad engineers. And I'd be applying to so many of them. And it got to the point where I'd just apply for whatever, even if I wasn't that interested in it, because I figured maybe if I get a job, I'll realize I might be interested in it, or I'll realize that, you know what, that's actually not what I want to do, and that solidified it.
Yeah.
But it got to the point where I still didn't have an internship. And
this was your first one still?
This was my first one. So it was 6 months after everyone else had started getting internships. And I was talking to my parents about it and saying, look, I don't know what I'm doing wrong. I understand that I don't have a HD or a distinction average. If you look across all my subjects at this stage, the ones that I'm interested in, you can tell I'm clearly interested in. I'm getting the HDs and distinctions, but everything else I'm getting the pass on the dot. And it meant that I was just not as competitive because at this stage they weren't really. They were filtering through uni students' resumes by WAM and your GPA, as opposed to your skills and your ability to problem solve. So I was talking to mum and dad, and they were back in Hong Kong still at this stage, and just went, look, can you just help me review my resume? Because obviously that's the stage that is not quite up to scratch at the moment. And Dad went, oh yeah, actually, at my football club, there's one of the guys, his wife is an engineer. Let me give her your resume and she can review it for you. I'm sure she'd be happy to and give you lots of good feedback. So he was doing that on the off the football field one day, and one of the other guys from the other team or opposing team, whatever it was, overheard this conversation and came over. I was just like, oh, I'm also an engineer. Let me have a look at her resume, give her my email, reach out, we can have a chat. and go through it. So I was talking back and forth with him, not realizing at the time that he was actually the director of the company.
Oh, really?
And I thought he was just like some senior engineer to start off with. And it went really well. And it ended up manifesting into an internship. So I actually got to go back over to Hong Kong for 6-7 months to work with this company. And it was a really good shock to the system in many ways, because it was a German-owned company operating in Hong Kong, and a lot of the subcontractors were like Italian subcontractors. The director was Aussie, and I was coming in, and there were all these people in the office, you know, speaking German, speaking English, Cantonese, Italian, and I was in there reading these documents that were in German and Google translating, trying to figure out like what different type of bolts were in German. And you know, it's not simple when it's in German. So it was a really, you know, fortuitous way to get an internship. But the more I talk to people now, the more I realize that networking is, you know, fortunately or unfortunately, there's pros and cons to it still. Networking is one of the best ways to get into this industry or into jobs, and to build relationships with people to get you to a point where you are able to get jobs and thrive in jobs as well. And it's definitely something that I've brought with me along my career journey so far.
I completely agree. You know, I think sometimes it's really hard to set yourself aside or set yourself apart from people, especially when you're in a big year at uni and you've got like, you know, heaps of guns behind you, like, you know, applying for things with super high UAIs or WAMs or whatever they call them. I can completely feel that. Yeah. And, you know, very candid, my WAM was also 75.
Oh, so. Way better than mine.
Hang on, is it? I thought it was the same.
No comment.
But what I wanted to ask you about was some of those early times and your experiences in Hong Kong. And I know that when, you know, you might have rocked up to site and, you know, you might have actually been out of your comfort zone, not being able to speak the language or the 3 languages that are on the site.
Yeah.
Then you're also rocking up as a female in a time when, you know, it was super male dominated back then. Yeah. What did you learn from that experience kind of back then, and how did it shape the Kate that we've got in front of us today?
Yeah. So I mean, growing up in Hong Kong, I picked up a bit of Cantonese, but by no means am I like conversational at a site level at all. But the good thing about engineering is people respond really well to you getting on their level. And sometimes that does mean, you know, dropping a couple swear words. And I'm very good with my Cantonese swearing still. My tones are perfect. Everything else, my tones are completely gone. But swearing is still there. And I think just breaking that ice initially helped, because as you were saying, I rocked up to this site where the only other females on this site at the time were the cleaners. So they'd come in and clean, and I'd be walking around this site and people would just stare at me and go, who is this weird
running
English
around the
girl?
site swearing at people?
Yeah. Not quite, but close. Yeah, and look, like it was so unheard of to have a woman on this site that even when I was going to the toilet on site, because they never had to accommodate for women on site, I'd be walking into the toilet and there'd just be men in there shirtless, like peeing in the toilet with the door open.
Oh my goodness.
And I think after a couple months they really got used to it. But, you know, it's as much of a shock to the system for them as it is for me. So I didn't necessarily hold anything against them for not knowing how to act. But, you know, it is still something that as a woman in construction especially, you kind of have to come to grips with, is that even though we're trying desperately to get more women into the industry and on site and in non-traditional roles especially, you're still coming into a work environment that is not built for you necessarily. And it does sometimes take a bit of guts, cojones, to get through some of the experience experiences that you will have on site. Definitely needless to say, that doesn't make it okay, any of the experiences that some women do have on site. And just because there's an aspect of some of these experiences being normalized doesn't mean you shouldn't go out and say something about it.
Yeah, completely.
Yeah, and I had an incredibly supportive team, luckily, in Hong Kong. And it really helped sort of set a strong foundation for me loving being on site and getting to work with lots of different people and learn how to swear in all these different languages.
Yeah, the absolute highlight from your Hong Kong trip.
Absolutely.
So when you came back, so you'd done your experience, you'd come back to Australia, and I understand, or one thing I really wanted to talk about was kind of how you worked your way into humanitarian work and doing humanitarian projects, because I think that's had a real fundamental way on, kind of had a fundamental effect on the way you approach things. So how did you first get into it?
Yeah, so I mean, growing up the whole time, my parents always instilled a very kind of charitable mindset into me. I mean, my sister and I, when we were 3 years old, we were making Christmas cards and selling them out the front of our house and donating all of that money. So I kind of always had that in me, that I had sort of this, I hate saying greater purpose. It's not a great phrase, but
Vision.
I had this vision that, you know, if I'm going to develop these skills, I can use them to give back somewhat to communities, and in the meantime learn a lot from these communities and develop my skills through that. So in first semester engineering, we did this subject where we got to work on an Engineers Without Borders project. And a lot of the students that are in that class, that come through that class, kind of groan and moan because they come into engineering and think that they're going to be doing the maths, they're going to be doing the physics and making robots. And then all of a sudden they're having to learn how to work as a team and how to empathize with communities that aren't their own, and learn how to build solutions as a group and write reports on these solutions. And a lot of people kind of see it as a means to an end. You just have to do it to get to the degree. But it really excited me. I loved this idea that you could learn from what companies like Engineers Without Borders were doing and learn from all the communities that they were working in and get to develop your technical skills in really fun ways. Like you learn how to implement engineering theory in really low resource scenarios often, or in scenarios where you're having to use tools or materials that are foreign to you but maybe quite common in whatever community you're working with. So I absolutely fell in love with it from that point. And then throughout uni realized that Engineers Without Borders were actually running these really cool overseas study tours. So applied to I think it must have been the first ever trip that they did to India.
Wow.
And it was fantastic. Like I learned so much from it, and it really grounded me and my view on engineering in a way that I try to bring into all types of my engineering practice now.
Tell us about one of the projects that you worked on.
Yeah, so in India specifically, so this first trip as a student, we were in this remote farming village outside of Pune, and we were all, I think there were like 6 of us in this one house, all sleeping on this cow dung floor. And you know, it's a bit of a shock to the system as like someone who's grown up in Hong Kong and Australia in these very flashy, very privileged environments. And then you're going in and sleeping on cow dung. Your instantaneous response is to go, ew. But when you actually talk to them and learn about it, you realize that it's incredibly sustainable. It actually is one of the best ways to control heat and cooling of the house. So it's like this fantastic natural resource that's abundant in their community. And like even small things like that you learn from. So we were staying in this house, and witnessing a lot of these things that to kind of a Western lens are a bit shocking. The way that they were cooking on fire, but the things that they were burning for the fire were maybe things that we wouldn't dare to cook with, like maybe a lot of biofuels, which are great sources of fuel, or burning plastic, which is not so great for the health. And a lot of homes were burning these indoors and filling the house with smoke that was terrible for their health. We were in a house that actually had like an outdoor cooking section. And, you talk to them through translators, and you try and figure out why they're cooking like this, because people have told them before of the health issues of the smoke. And, they respond in, well, I wouldn't want to cook with electricity because you don't get the same flavor. And the flavor palette of that char that you get is what they love. It's what they're used to. It's objectively better.
It's way better.
Yeah. And you really realize that there's a lot of complicated, cultural intricacies to a lot of the problems that often, these white knight engineers come into these communities and go, oh, gross, you're doing this. We do it way better where I'm from. And then they come in and just implement these solutions that don't work because they haven't taken the time to ask why they're doing things the way that they're doing, and what the reason is. And the subject that I talked about before, the Engineers Without Borders one, I've been tutoring that now for a while, since 2018.
Full circle.
Just to go on like a complete tangent. And one of the really fun examples I use is of this case study of this American non-for-profit that went into a couple different African communities and saw that women were still walking to get water. And they went, oh, this is ridiculous. This is like anti-feminist. This is terrible for the community. Women could be doing so much more instead of walking to go get water. And instead of actually asking the community, they came in and came up with this very flashy solution where it was essentially like a merry-go-round, where they would build these wells and then get children to play on the merry-go-round, and that is what would pump the water up. Sounds very cool. They got all of this investment. They had celebrities endorsing them and like massive companies endorsing them, and got millions of dollars to implement these things, and implemented it in a couple communities, and then just left. And 2 years later came back and no one was using it. Surprise, surprise. And realized that they hadn't actually asked them anything about their cultural ties to some of the practices that they were still doing, and realized that the community viewed these playgrounds as somewhat like child labor. So, which, when you think about it now, it is. You're making the children work for the community's water. And they also didn't actually think about the fact that children aren't as strong as fully grown adults. And to play on this merry-go-round actually took quite a lot of force. So what ended up happening was the men and women were playing on this, well, not playing, they were pushing this thing around and around to try and pump the community water. And it was just, degrading at best. And, this is quite a good parallel for a lot of engineering you see, especially in, actually most engineering spaces.
100%.
Yeah. So you get these people come in and go, I have this great engineering solution. I think it could work for your community. Let's try it out. And then often they will or won't iterate from that, because often when you come in with an engineering solution, you get quite stuck on the idea that this is the best solution, as opposed to going through the process. And this is something you learn quite a lot in the like engineering for good space, is that the most important part of the engineering process is the empathizing phase, and actually coming in and learning who it is that you're building something for, learning what their exact problems are. And there's lots of different tools you can use, like the 5 whys method, where you ask them a question about their problem and they give you the answer.
I want to put you back in your boots in India.
Yeah.
So you're in this community and you're talking to them about, how they can start implementing a new way to cook.
Yes.
Right? Or maybe that's the project. So how are you actually picking up information from the local community? Because, I'm sure that they don't speak English.
Yeah.
And I'm sure that you're trying to overcome all these cultural barriers.
Yeah.
What was it that you were doing in those times to try to connect more and to empathize more with the local community?
Yeah. So we had translators that were definitely helping, and I think the father of the family spoke Hindi as well as Marathi. Okay. So it was lucky enough that we also had someone who spoke Hindi in the team. So not only did we interview them, but we also observed them just in their everyday life and watched how they did things, why they did things, and sort of probed and asked lots of questions. And we came to the conclusion that trying to sort out, the stereotypical problems of cooking and toilets, we actually realized that a lot of their food produce that they were harvesting, some of it would go to waste, and they had no refrigeration because they had no consistent electricity. They'd have rolling blackouts and they wouldn't know how long it would go for, and they wouldn't know when they would come. So they couldn't actually plan around it. And similar with their water, they had like a little tap and they wouldn't know when the community water would flow in and for how long. So they'd be running around with buckets. So observing this, we realized that pickling was their only form of food preservation and drying. And we wanted to give them the opportunity to extend the life of some of their fresher produce, even just for a couple of days. So as a group and with the community, we came up with this idea to use like an ancient technique of using porous clay pots and insulating them. So you essentially take 2 layers of pots and then you insulate them, and there's multiple different methods of then cooling the produce within the central pot. Mm-hmm. You can either then bury it, or you can put in like dirt or rocks or clay, and then you can pour water in as well, and that can also keep it cool. Okay. So we ended up building a very low resource prototype of this solution for them and presenting it to them. And not only did we have to present it to the family, we had to present it to the whole community. And this really put into perspective that, you're not here as this savior bringing your engineering knowledge. I mean,
and technology.
Yeah.
And stuff.
I mean, come on, it's a bunch of engineering students. We're not like 20, we're not engineers with 20 years experience in this particular field. Like, we're coming in with, 2-3 years of engineering learning. And, the importance was about coming together and being creative and coming with the community. So as we're standing up there presenting, we really realized that the value is in this process, making sure that you understand the problem that they had, and if they thought it was actually a problem, and not just bringing in your biases and assuming that it's a problem just because you witnessed them do a certain practice or not. And that whole process I fell in love with, and really the aspect of engineering for good and coming in as more of an educational piece for people like me, where we're going in to learn more about how communities are doing different types of engineering in their everyday life and problem solving, really made me fall in love with it. So I applied for a couple of years later, applied for a second trip with a different company, Unbound, to go to Nepal as a student again. But this time it wasn't an engineering specific trip. It was all around the human-centered design and design thinking and humanitarian sort of solutions in Nepal, but cross-disciplinary. So it was students from all across different Australian universities with all different backgrounds. So we had like marketing, media, science, engineering, all sorts. And again, like that just solidified more my love of learning from communities to bring value to the engineering skills that I'm developing and to develop them further. So this Nepal trip as a student was really fun as well.
Tell us about it.
So it wasn't, this time it wasn't so much engineering for good, it was just engineering for convenience in a really inconvenient environment.
Difficult spot.
Yeah. So one of the families in this mountainous community were building a new home, and they were carrying on this really tough trail all of the building materials up and down from this little plateau. And we went, there's got to be a better way to do this, and talked to them about it, and they loved the idea because they also agreed that it was quite a slow process.
Please have designed a zip line or something.
Yeah,
no.
Good guess. But what we realized is all of these communities around this area in Dulakel had a lot of scrap metal and scrap motorbike and bike parts.
Oh, wow.
So what we did was we designed this zip line to go from like the upper plateau where you could bring material in a lot easier. I mean, it still wasn't that easy, but a lot easier to bring to this first section and then to zip line it down.
Wow.
And
Let's go. That's a great idea.
and we were using old motorbike parts, and like we were using all the different brake components and the pedals from a bike so that they could pedal it up and down. Because the first couple trials that we did, we released like 50 kilos of rubble on this zip line to test it. And it just got to the end. We hadn't even thought of breaking it.
At the end.
It got so fast.
Oh, God.
And it hit the end of the zip line.
Destroyed the
no
pulleys.
braking involved, obviously, because we're like fourth year engineering students at this stage. And it just exploded everywhere.
Oh.
Luckily, no one was.
Luckily it wasn't something
Luckily, no one was there.
Is this thing for people use too?
No, absolutely not. And we had to make it very clear that this is built for just building material. And we then, after talking to them quite a lot, realized that after the building of this house was complete, they could use the same system in reverse to bring back all of their produce back up to a plateau. So we made this prototype, and I think the prototype was the one that they ended up actually using. So we made this prototype for a use case that was, helping one family build one home. But they ended up being able to use it in other ways. And the great thing about this program was that the next cohort of students came in and they had the opportunity to enhance the prototype that we'd built as well. So they didn't necessarily have to work on a whole new project. They could find problems with the existing one that we made that the community have tested out over, 6 months. And of course there's going to be problems.
Yeah. No brakes.
We had, no brakes. But we also only had a week to build it after a week of designing. So, after working on large engineering projects, you realize that a week is really nothing at all. And it was just fantastic. And the funny thing is, I was using that skill of being able to talk to all different levels of people in personal ways. And I reached out to the CEO of this company and the founder and just went, hey, I absolutely loved this. And, there are all these students who are coming back to university after these profound experiences. And then we just have to go back to uni. And we don't have the opportunity to share our learnings and share these cool things that we've done and these cool communities that we've been able to go to. So I want to, one, have the opportunity of going back as a facilitator and being able to work as, the person who organizes aspects of the trip and runs the trip and runs the...
How exciting.
Yeah. was so good. And he kind of gave me a bit of a look over the phone. I could hear
You
it.
could tell what his face looked like.
But then I also said, because of this community building aspect, I really want to also start like a group within the university. Ended up starting a society for people who had been on these trips to just come back and hang out and talk about them. And I think that might have been the point at which he was like, all right, yeah, I'll give this, crazy 24-year-old a chance. So I went, I think it was 6 months or a year later, on a trip as a student facilitator. So like unpaid, volunteer, flights, accommodation, food paid for. And I was like, hell yeah, that's a great opportunity. I don't need to be paid because I want to be doing this stuff. And as a student, I had to pay to go. So of course, and just loved it. And, I learnt a lot from that. There were a few things that I did that weren't, so great. I was focusing so much on teaching them, the students, how to be empathetic towards the community and learn from them, that I forgot in the process to also be empathetic towards the students. Oh. And it was a really great learning opportunity for me of like, I'd trained myself so hard that I had to, instill in them this idea that you're not a white knight, you're not coming in and you're not their savior. You're here to learn. That's it. You're not here to make their lives easier. If you happen to do that, great. But this is a learning opportunity for you and nothing else. And I'd almost forgotten that it was the same thing for me. It was a learning opportunity for me on how to empathize with my group, which was the students, not necessarily the community now.
Yeah.
And that also was a great thing to bring into my engineering practice now. That's and how I operate within a larger construction environment now.
That's really interesting. And it's funny because on our last episode, I interviewed a geotech named Dave Oliveira. He said his motto was, the best way to learn is to teach. So if you want to watch that episode, make sure you go back and watch episode number 3.
Definitely will.
What I wanted to ask you about next was, you're doing these projects in these remote communities, and then you come back to uni and you're getting involved in more involved in your mechatronics. And I wanted to ask you about those initial kind of, once you finished your degree, those initial times where you went out into the workforce and you started kind of applying your engineering and really getting stuck into the industry. And I wanted to ask you from a perspective of, like you're doing all this amazing stuff out there, and then you go and just get a normal job. Like, what the hell? How does that go down,
Yeah. So not quite. I actually, came back, and then it was, 6 months later about time to do my capstone thesis. And I went, I really love this whole engineering for good, like working with communities that actually have an engineering need. So I had found this really cool local startup that was building these ankle foot orthoses for children with like cerebral palsy. And when I want to, work with them, and found my capstone supervisor because he came in and just talked at one of our lectures, and I was like, yep, him.
He looks cool.
He looks cool. I'm going to go up and just ask him. And again, like, who gave this girl the confidence? So managed
Someone's got to,
yeah. So managed to sit down and get him to agree to do a project that I wanted to do, which, oftentimes students will come in with what they really like and what they're good at and what their interests are, and they'll come together to figure out a project that also is in the best interest of that lecturer or that school or whatever it is. Or some people do it with industry as well. And managed to do this great project, and ended up getting my second internship this same group. So not the startup, but with the group within UTS that my supervisor worked for.
Okay.
And they did a lot of engineering projects as the intersect between university and industry, being able to bring all of those different resources together. And the great thing about this group that I really loved was you were doing a lot of really high-tech solutions for large industry. And then also they had another group, which was their social group. And I got the opportunity to work over both teams as a mechatronic engineer, doing these really cool low-resource mechatronic solutions for low bono, pro bono, or like other NGOs, charities, using grants as well. So the university offered a few grants, which we managed to get matched by the mechanical school as well.
Oh, wow.
Which was great.
So you're delivering these kind of these intensive projects where you really, you're given a certain amount of money and you do the whole plan for the entire project and punch it out. Yeah.
So it was often a 1, 2, 3 man show, woman show. And we were bringing, in some cases, bringing the project in and then going through the entire design cycle, which I'd learnt through uni and on these trips. So going through the empathizing phase, finding their problems, going through the design phase, the testing phase, all of these, the report, and then the presentation back to them and handing everything over, sometimes all within $10,000. And I would also have to budget my time to that as well. So we were doing things very low resource. So often I'd be actually down on the tools with all the different like aluminium extrusions and building the robots myself, which was great. And I think that definitely developed my understanding of the full engineering process. I think in a way sometimes that these large projects takes 5, 6, 7 years to be able to get that same understanding.
Can you give us an example of one of the things that you implemented?
Yeah. So one of the projects I did was actually back with that same company I did my capstone for. And they were 3D scanning, 3D printing these AFOs.
What's an AFO?
Ankle foot orthosis. Okay. So a type of like external prosthetic. It's not a replacement of a limb, but often you wear it around your foot to help with your plantar and I've forgotten all the terminology now. It's been a while. So I built this automated fatigue testing machine for them because one of their previous capstone students had actually built this manual one. So you'd sit there and then put the 3D printed AFO in, and someone would be manually moving it 10,000 times or something. It was a fantastic first project, and it did exactly what they needed to do at the time. But they'd now gotten to a stage where they had to prove that it was these AFOs that were 3D printed were as effective as the traditional methods of like casting. So I went to automate it, and then after doing the engineering realized that there were a few things like the angles didn't quite work out when you started to motorize things, so ended up basically redesigning the whole thing using the same bones. It was actually like quite a good design to start off with, and got to present that back to them, and it was fantastic. They were so excited and managed to do that whole thing in $10,000.
Wow.
So used all the.
Sorry, I didn't mean to cut you off. I'm not a mechatronics engineer, right? But I'm kind of interested to work out, like, what is it that you're designing here? So because I think it's interesting for people to know exactly what we do here. So it sounds to me like you've got the actual prototype of the limb.
Yep.
And then you've got something that's fitting over the top of it that you've shaped and designed in 3D and 3D printed. And then what about all the systems and stuff? So like, how do you talk to the 3D printer? You know, how are you controlling it? Like, tell us about kind of that whole process, because I'm keen to know what it is that you mechatronics engineers actually get up to, you know?
Yeah, it's not all 3D printing. But yeah, so this company, their whole kind of IP sits around this scanning and printing part of the AFO. But what they do, or what they did, I haven't really kept in touch with them that much. But what they did do was a technique called photogrammetry, where they'd get the kid to sit down and put their foot in, and they'd have an array of cameras and then take lots of photos and in software zip them all together to create a 3D model of the exact foot. Then they'd be able to model the AFO around that and then print it. So the printing technique they used was not like your typical desktop FDM printer that most like hobbyists would have. So an FDM printer is kind of like a hot glue gun where you deposit material and build it up slowly. And a resin one is sort of similar, but you're curing resin as you go. Whereas the one that we were using, because you're putting this on children that have often like sensitivity issues, you need to be really conscious of the roughness. And that was my whole capstone, was about how do we optimize the surface roughness.
Okay.
So what they used was this really great like multi-jet fusion. So if you think of an inkjet printer, like a normal printer where you deposit from like a little head cartridge, multiple little dots, and then often it'll cure it. It's the exact same process. So you have a bed of powder. So in this case, it was nylon that was like biocompatible nylon, so you could wear it and it wouldn't irritate human skin. So you'd have the powder bed and a big inkjet printer cartridge essentially would come across and deposit this like glue-like substance, and then it would have a UV curing light that would go just kind behind it. So it would cure it immediately, and then it would drop down and like wipe a new layer of powder over. And these layers are like 80 micron. So they're very, very small, and you cannot, using this technology, you can't see the layers the same way. And also because it's powdered, you can't see layers the same way that you can in the FDM, which is like the hot glue gun style. So it was a sort of perfect use case for something like this, where you needed, you needed the sheer stress to not be as terrible as in the FDM, where along the layers you can just crack it with your hands.
Completely.
Like you couldn't pull it.
So this thing's working full in 3 dimensions.
Yeah,
and
essentially.
Got strength in all orientations.
Yeah. So like very cool technology, and fantastic that the university had purchased one of these and had set it up just in time for me to start this project as well.
Good.
So, I mean, everything about this was just, luck, fortuitous that I managed to want to do this project, and that we just happened to have the exact printer to do a lot of testing with it as well. So, and one of the things I did as part of my capstone as well was print all of these test pieces in different areas of the printer as well, and on different angles, to see how that would impact all the different strains and stresses on the material, and try and optimize the smoothness of the surface compared to the strength, so that
so you're kind of like orientating it differently in the printer, so that you have your planes in a different orientation.
Yeah, exactly.
Wow.
Yeah.
And what was the result of that?
Found that, I mean, this is getting a little bit technical now, but we found that on like a 45-degree angle in sort of 3 dimensions, and as central to the printer as you could get, was actually the best for both of those. But then, the great thing about this technology is that whatever powder you don't use, you can reuse for the next print. So it wasn't that much of a cost issue to do that. But if you were using another technology that's not necessarily the best use of space, if you're just printing, as central as you can. And there's also the time aspect. You have to wait like 16 hours for it to print. So if you're only ever printing within this small like range of the printer bed, then you're also wasting the excess. But, the great thing about printing is you don't have to print like 50 of the same thing. You could print like these couple AFOs in the middle, or the test pieces that I was using, which are like dog bones. And then print whatever else you need around.
Very cool.
So that was the sort of like 3D printing side of things. And then in terms of the fatigue testing machine that I built to test these prints, that was then, like designing the system, designing the software, designing the electrical component of it, so like making my own little PCB, stuff like that.
So cool.
Yeah. And the sad thing is I've probably lost quite a lot of these skills now, but the interest is definitely still there.
So because once I tried to make a light suit for a festival.
Yep.
And I spent a lot of time in is it J-Bro?
Oh, I wouldn't even know.
Oh, I think it's called J-Bro. It's one of the electronics stores, and you like walk in there and it's like so
like
cool.
J-Car?
No, J-Car? I think it might be J-Car.
Yeah.
Is that an electronics store?
Yeah.
And I remember going into this shop thinking, gosh, what are these people doing with all these bits of gear, like all these little components? But it's like when you dive into it, it actually feels like you're walking into a candy store because you've got all these
it's so cool. I love it.
Pieces that you can play around with. And I still haven't had the chance to design something with one of those little
like the Arduino boards.
Boards. That is something that I really want to do in my time.
Yeah, it's good fun. I think the great thing about tech like that, and with the engineering skills that you have, even if you're not a mechatronic engineer, is if you give yourself a project, and this goes for all engineering, if you have a project that you really want to make work, you can figure out how to make it work. And you can go out, do the research, get all your Arduino boards and stuff. But definitely get that light suit done.
Well, the light suit was done and it was a raving success.
Oh, amazing.
I actually designed it with a little switch so I could switch it on and off to
cool.
the music. It was actually pretty sick.
Engineers.
So when so you're working on these really small, intense projects and you're in charge of, you're fully accountable for the entire thing, and it might happen in a few weeks. And then you get into communications on major projects.
Yeah.
Where does that come from?
Yeah. Look, it's a very good question. Because sometimes I don't even know. So I had gotten to a stage working for this, essentially what was a startup that was working as a research unit out of the university. And I really loved it. But as you said, it was all quite small scale projects. And even our largest scale project was sort of not much in comparison to like the $5 billion projects that you could work on in these major infrastructure projects. And I thought, look, I would love to get exposure to the engineering process from more of a structured way. So I wasn't necessarily looking for jobs, but and at this stage I'd applied a few times for some jobs with Engineers Without Borders and just didn't have as much experience as some of the other people who had like 30 years experience of actually going and doing the humanitarian aid in other countries. So I got this call from like a hiring manager or one of the PNC ladies at UGL, and she was like, "Oh, I found you on LinkedIn. We've got an opening on the graduate program. I think you should apply."
So you hadn't applied at this point?
No, I hadn't applied.
You got proper headhunted.
Yeah, which feels really nice, you know. And look, despite all of this, I've still got crippling imposter syndrome, as most engineers do, and female engineers especially. But yeah, so I had her reach out, and it was really funny because I was like, oh, how much is it? And she gave me the how much it was, like, package. And I went, oh, like, working where I am now, plus tutoring at the university, because it's all the same uni. I don't get taxed as 2 jobs, so I'm earning more than what you're offering me, so no thanks. And kind of left it there, and then like 2 weeks later she called me again. I was like, no, I really think you should just like come in for a conversation and let us talk you into it. So I was like, you know what? It's about the time when I've been thinking about getting onto bigger projects anyway and learning more about like the large scale engineering process. And I wanted a bit more of a structured opportunity to go up in my career, which, for anyone who's worked at a startup as an engineer, there's not necessarily that many positions to go into. So I went in and had a chat. Turns out that was the interview. And like rocked up to their head office with a view of the Sydney Harbour and was just like, oh, you know what? This is actually kind of cool. So
I want to know, because I know we caught up before, Kate, and I want to know the question that she asked you and what your response was, because I think that's absolutely hilarious.
Yeah. So she was like, as part of this graduate program, you'll get a couple rotations, but the first rotation you'll be in, you'll start off as a communications engineer. And I was like, yeah, cool. Okay. I know what that is. And then went in for this interview, like completely misguided, thinking that comms was, like your network stuff and your communication protocols, coming from the Mechatronics background. And, an element of it definitely is. But no, it's like radio and public address and phones and all of that sort of stuff.
Wow.
Telecommunications. So I'd gone in thinking,
You
comms.
studied like for the interview, all like prepared.
Yeah, I mean, I came in going, like I've worked on sites before. In Hong Kong, I was working as the testing commissioning officer. So I've gone across like a different range of sizes of projects, and I've done the engineering process. So all of that they were really happy with. But then when it came to the comm stuff, I was like, yeah, Modbus, I know it. And I'm glad it was a graduate position that I was going for, because they were like, no, do you know anything about telecommunications? I was like, oh, no. And they were like, oh, that's what this role is. But no, it was funny.
Still got the job.
And I've still got the job. And I found out, 5 years later, I actually quite enjoyed telecommunications, and that the networking side of it as well still gives me a little bit of like my mechatronics spark. I miss the robotics aspect of things, but it's very creative, and being able to learn entirely new technical skills is also good. And as a mechatronic engineering uni, you do a couple electrical engineering subjects. So I'm pulling on that knowledge a little bit more. Not that it was ever my strongest strength during uni.
I really want to know about, So you've gone into these big projects where you're fully accountable for, it could be a full design package for, it could be a tunnel, or it could be a telecommunication system for a transmission line project, or,
Yeah.
So what was that like for you coming into these bigger projects where it's not so fast paced and you're not really under the pump to really deliver things quickly, but at the same time, you're fully accountable for the entire system on what could be $1 billion project or $1 billion asset at the end of the day. What was that kind of part like for you?
Yeah, so the first 8 months of coming into this role, I was working in the defect liability period, which I'd never even really heard of. I didn't realize that you couldn't just hand over a project and, thanks.
So for people that don't understand that, maybe do you just want to explain really quickly what a DLP is?
So as part of your contract agreement with a client, you will hand over the project ready for use, for public use, whatever it might be. And then you stay on site, or a reduced team or like a specific team for the DLP will stay on site.
So like maybe like ironing out particular defects.
Yeah. So during, the first couple years of operation, especially of something like the metro, you find a couple things, especially because, it's the first metro in Australia, automated train system. And even though we had experts from around the world come and help us out on the design, it's still in a completely different context. So you find a lot of minor defects or, quirks within the system that you hadn't
bug
quite...
in the code. Or
Yeah, whatever it might be. And, at some points it was like we just needed to do a firmware update on certain things to align it. Yeah.
Update your system.
Yeah, so I was working for 8 months on this DLP, going through and testing out and running test programs with, civilians off the street and paying them to sit on the train. And I was playing these horrible sounds out of the public address speakers for them to listen to for like 8 hours straight. Poor things. Sorry, they were getting paid. Just to find defects. So it wasn't necessarily as well reactive fixing of the system. It was also, sometimes people would say, oh, there's maybe something here that is not quite working the way that was intended, and then you can go on like the investigative process to figure out what's actually wrong. So it was really cool. We got to work with radios, the public address system. I got to like run a program to replace some antennas on the trains, which was really cool. So that was kind of my first exposure to these projects. But it didn't really set me up to get a grasp on what a full design process was like on one of these projects. So from that, I then moved on from metro onto road tunnels, which is where we met. And then, my boss, who's fantastic, was like, I think you're doing really well. I'm going to give you the opportunity to have ownership over one of the smaller design packages, which means that not only are you doing design, you're going through the entire process. So all of the safety and risk, you're working with like the systems assurance team to get all of that. You're working with them to do like the RAMs and FAMICA analysis, all of that stuff, as well as the design, the network, the interfacing within the company, as well as to any of the external subcontractors, and then also going through the process of going out to tender to find suppliers for this solution, doing the technical comparison and like the contract comparison, pricing comparison of these suppliers to pick one. And then also managing that. So I was running, like the monthly meetings. I was managing their input in as well. And so that was a couple of years, and going through this entire process was, at times slow, which is not what I was used to, but at times incredibly fast as well for the amount of documentation that you have to do on this scale of project. Sometimes you'd be sitting there and like there were occasionally times where I'd, taken a bit of a longer lunch break. So I had to stay until very late at night to get the submission out, because not only do you just do the design and then submit it, you have to go through stages of design. So you have your first DCD stage, which is your like 50% design complete. And then you do an internal submission first, where all of your interfacing packages get to review before you then submit to the client.
So this is like an external kind of stakeholder or external review from within the project.
Yes.
Everyone kind of putting their input onto your package.
Yeah. So who was reviewing it was like the safety team, the quality team, the controls team as well, because we had quite a lot of interfaces with them. other, like the mechanical team as well, because, for example, this package was for emergency telephones, and all of my phone assets were being free issued to another supplier who was building the cabinets. So I wasn't in charge of designing the cabinets, another team was. So they then had to review our design to make sure that it all aligned and that, you know, the phones fit, and the human factors assessment had been done so that people within like 95% of the height range can reach this phone effectively, or in the cases where it was like the disability bay phones, wheelchair users could effectively use it and get to it as well. So many interfaces that you have to think about on projects this size that, you know, I hadn't really been exposed to before. And I learnt, you know, sometimes the hard way that...
As we all do.
Yeah. And I think the great thing about being on a project this size for so long is that you get to go through the process of the design and go through all this documentation and the reviews from DCD to SDD, so substantial detailed design, to FDD, final detailed design, and in my case have to resubmit that one a few times, to issued for construction, and then actually get to see some of the construction of that as well. And you get to learn where some of the designs weren't maybe strong enough for the construction case in which you had them in certain areas of the tunnel, for example.
And I can imagine that, you know, as an engineer who's really passionate about the stuff that you do, you know, it's really important to be able to see that whole process so you can actually get a grasp of the areas where you might need to improve the designs.
Yeah.
Because, you know, we are always improving and we are always pushing forward. I wanted to ask you about, you know, I feel like you got this innovative mindset that you've applied through, you know, working at your startups and tech kind of space that you've brought into kind of major projects. And I want to kind of ask where that balance is. And I know that you had a couple of really good mentors that allowed you to test some systems and some principles. I just want to ask you about how that interface of innovation is maybe a little bit different on major projects.
Yeah. And look, it's an interesting thing because obviously I've come in from like a pretty high-tech university-level robotics background. And then to come onto these major projects where things are done with such rigorous process that it's often very difficult to completely upheave the process. It's often about small incremental improvements or optimizations.
The process is there for a reason.
Yeah, exactly. And whether it's there because it's the cheapest, fastest, best way to do it, or whether it's there because of a safety issue that's happened before, often there's quite legitimate reasons, or actually all the time there's legitimate reasons as to why it exists. But having said that, now that there's all this really cool tech that exists, sometimes these processes are slightly out of date and they can be, again, optimized. So that's the sort of thing that I like to bring in to these projects and to kind of just, you know, trigger a little bit of thinking. And sometimes it's completely out of the budget. But sometimes it's also, you know, you'll get a grad with a 3D printer at home who's super keen to, you know, test something out. And, you know, often these companies are more than happy to give you $30 to buy a reel of plastic to print something at home and test it out. Or, you know, because I had still such a strong relationship with universities, and UGL also has quite a strong relationship to some of the universities. I also was super keen to get uni students on board as well to do things. So along with one of the unis, we jumped on as an industry partner to help give a project or projects to students who were struggling to find their internship because of nothing to do necessarily with their skills or their grades, but some of them it was just because they were international students and the working rights didn't align with a lot of the requirements for undergraduate engineering interns. So got to, you know, build some pretty cool projects for like GPS logging devices and stuff like that. So that was a really cool team from UNSW that built that one.
Okay. One thing, like, I wanted to talk about where you think the future's going with engineering. And, you know, there's a little bit of a buzz around AI.
Yeah.
Which I'm happy to talk about.
Yep.
But I really want to talk about automation with you because automation's something that's really big in mechatronics and in electrical that maybe, you know, other parts of engineering haven't yet taken advantage of. I want to hear what your thoughts are on where you think engineering's going and where you think, like, you know, where people can focus on for study or where you think the industry's going.
Yeah, look, I have where I want the industry to go compared to where I think it will go. So where I'd love to see it go is, you know, implementation of more automated systems and like automated tools. So not removing the human component, because that is I think quite important to have in any construction engineering environment, but to give them the opportunity to do things with maybe more precision or saving them from exposure to high vibrations. So, you know, when they're like manually drilling into a ceiling, like there's no reason why a human necessarily has to do that exact work.
Completely.
When like a robotic system could do it perfectly fine. Or, you know, like overseas, there's things like robo-riggers being implemented, or, you know, some really cool tech where you can now put like cameras onto hard hats and track the progress and actually like bring that back into your project management software and compare the progress as per like the camera view around site to your original program.
Well, how good would that be to check where there's issues?
Yeah.
Like, oh, this bit of wall hasn't moved for the last 6 weeks.
Yeah.
And you haven't heard about an RFI or something like that.
Yeah, exactly. Or even like things that now track the use of plant. So if you've got like a digger that's been sitting there for a week unused, why? Is it that it's been broken and no one's had the time to go and get it out of its spot and fix it? Is it that people didn't know it was broken because whatever line of communication didn't spread across to where it needed to spread? Or, you know, is it that it just wasn't needed because material didn't show up on site early enough or as planned? And then if you start tracking this and bringing in the smarts to actually manage this data and data, as a Hong Kong person would say, and actually consolidating it all and starting to optimize process, you can then start to reduce a lot of the downtime on sites. So you're not replacing humans with robots or anything. You're just helping them figure out, well, okay, this plant has been sitting here for a week unused because, you know, the steel beams didn't arrive. Maybe we could have used it over here instead for that week. And that would have saved us X millions of dollars when you're talking something at this scale sometimes. So I think that type of engineering and tech and innovation is where I'd love to see the industry go and where it is starting to go, which is great. But I think one of the issues, especially in Australia, is that you have you know, these processes really deeply ingrained because, as we talked about before, sometimes really valid reasons like safety or whatever it might be. And until you have proven use cases of robots, as an example, completely negating these problems, the uptake of them is quite low because, you know, it's a new thing. It's completely valid that there's apprehension to bring on these things on site where people don't necessarily have the skills to work around it without quite significant training. And then there's also the fear factor, of course, with a lot of people that they think that maybe bringing robots on will reduce their job, and it's about bringing them on efficiently. Obviously, there are some robotic use cases which do just completely replace humans.
Yeah.
But that's not the most effective way to bring them into the existing construction environment.
And are there any particular areas or things where you like you're focusing on where you think the industry is going? I mean, or maybe some advice for some of the generations out there on people like areas where people could look into.
Yeah, I think for all of, especially this is for a lot of the mechatronic grads and the electrical and software grads, particularly, or even those that are kind of earlier on in their career, it's important to keep up with these skills. I've lost now quite a few of my robotic skills over the last 5 years of not working in it. And, eventually the industry will catch up. And it might just be a bit slower than, startups or maybe a country like China where they have the resources to be able to implement these tech trials.
And the tech's right there too. Like
Exactly. So it's cheaper for them to, hop off and
completely
get it. And we have quite stringent laws and regulations on site around processes and tools and stuff. So it's then hard to bring in a robot, which, if you think of it properly in the construction environment, it is another tool, and there is no existing regulation around it. There's the the ethics of robots and AI in industry is not keeping up with how fast the tech is being developed. So if you're able to keep your skills up and your interest up, eventually you will find someone, like one of the senior project engineers that I had on site recently, who was just super cool with trialing things out, like 3D printing little devices to film progress of stuff or to mount certain testing things in places. You will eventually get someone who will support you in that, or eventually you'll get to a point where you are now in that position to be able to have $500 budget to be able to test something out.
Instill the psych in some guns.
But I think as well, one of my more critical opinions of the industry is that if they're not keeping up on a global scale with innovation and the scale at which innovation is now being implemented on site in a lot of different countries, we will start to fall behind as well. So it's important to keep those skills up, because eventually you will be a critical asset to the company that you're working for.
That's something I worry about all the time, and that's like my skills falling behind.
Oh, absolutely not.
And no, it's true. Honestly, it's something that I worry about, and it's something that we're all talking about all these crazy buzzwords around AI and automation and
digital twins, IoT, all of those.
And sometimes
words,
I'm like, am I doing enough? Like, am I really kind of doing enough? And I guess the last thing I wanted to ask you about is, what have you been working on, or where are your areas of focus for the next little while?
Yeah. So I think at the moment, something that's piqued my interest is getting back into figuring out what tech exists globally. So I don't quite have an exact plan yet, but I'd love to get to a point where I am more cognizant of what exists and whether it has successfully been implemented elsewhere, either in Australia or overseas. Better for it if it's been in Australia, because it means that the uptake of it will be a lot easier.
Yeah.
But just getting to a point where I can start to lobby people to testing out these things. And again, like I'm not necessarily in a position to be able to just rock up to like the CEO of like the company that owns us. But why not? if you do it in a way that's obviously not rude, because they're the ones with the
start by
knowledge
swearing.
and like the years, the years of experience in strategy. And I'm, an engineer that's seen things on the ground, but I by no means have any skills in broader business strategy at all. And, I'd love to develop that eventually.
Yeah.
But one thing that, I think people often forget is that as engineers, even if we, have fading skills or the fear of fading skills, we still have skills that the people who are making all these strategic decisions for the businesses might not necessarily have anymore. Because if I think about the skills that I had in uni and when I was working more in robotics, I don't have those skills anymore. Like it would take me a while to get them back up. And even then, the innovations of tech have moved so fast that what I learned and what I was practicing back then is not even, at the forefront of anything. AI didn't really, it existed, but it was like my friends doing PhDs on AI. It wasn't, ChatGPT in everyone's pocket.
And now every kid that's coming out of high school knows how to code in Python.
Yeah,
like,
exactly.
what the actual hell?
Yeah.
And here we are struggling.
Yeah.
Oh, that's a really good point, because I think sometimes we forget that, our skill as a young, keen engineer is actually being keen, being motivated, being across what the tech is.
Yeah.
And then sometimes that's all you really need to go and lobby with some, exec who that's actually what they need too.
Yeah. And
That's
being
what
able
they
to
need in
think
you.
left of field is really important, because I think a lot of the time, and it's, the nature of the construction industry, you get quite a lot of the same type of people, which is often middle-aged men, all in their like silos talking about this. And it's, something that I've talked with you about in great depth of bringing more diversity into the construction environment. But you then find if it's people who have been talking to the same people for so long, they might not necessarily realize what else is going on.
Completely.
Yeah.
I find it really difficult to imagine someone listening to this conversation and thinking, engineering sounds boring, like how is there not like scores of people trying to get into engineering? Like we do so much cool stuff. Like it's actually wild.
Yeah. And there's so many different ways to get paid very well in engineering too. So like, why would you not?
Yeah, exactly. That's like 100%, 100% my take. And it's, to be honest, it's something that I hope that we can change.
Yeah.
Having conversations like this, I'm hoping that we might inspire like one or two kids to pick up engineering or an engineering subject, and come and do the cool stuff that we do.
Yeah. Come
and work on robotics, 3D print bits for your ankle. Like, like it's so cool.
Yeah. Yeah. And like, even just looking at my career so far, like by no means am I, I'm not even halfway into my career. And like I've had the opportunity to do lots of different things. Like, I've gone overseas, I've done robotics, I've done social engineering, I've done major project engineering, construction, I'm now tendering, so
cool.
There's lots of things that you can do as an engineer. And when people ask me what I do day to day, the only consistent friend is Excel. Everything else is, quite different.
It might be changing to Power BI now.
Oh, God.
Yeah, but I'm so crap at Power BI. So, we come to the end of the episode, Kate. I think this has been a really, really amazing conversation. We've talked about some details of some of the work experience that you've done. We've talked about some of the transitions and some of the pivots that you've had in your career. And I think the message is, sometimes when you're approaching a new opportunity or something, I think sometimes we've got this tendency to think that we're not ready or that we need to keep thinking about things. But if there's one thing I've learned today, it's that you got to jump in head first and the rest will kind of work its way out,
Yeah.
So I really appreciate you coming in. I do have a little gift for you, Kate,
Oh, thank you.
which is your very own full send. Oh, I forgot I got to talk into this. This is your very own full send engineering shirt.
Thank you.
Thanks for making time for us.
I'm a real engineer now.
Yeah. Well, you're a full send engineer. Thanks for making time for us on the weekend and sharing your story. I'm sure people are going to get passion and feel that burn of really what makes being an engineer so much fun and such a cool thing. So thanks for coming in, Kate. It's been really amazing conversation.
Absolutely fantastic.
Cool. Thanks.